Oh, hi everyone. If you're not watching this live, make sure and check the notes for timestamps. We're starting a smidge early because I have to end late, so I thought I'm set up. I might as well get started. I won't do housekeeping until 7 minutes from now or so, so if you are watching this later, check that out. Live on Twitch, thank you, Mr. Certainly. And hello, Love the Factory. So Spook has a vet appointment this afternoon after this, so that's why I gotta get out of here by 3:30, or at least get off by 3:30 to give enough time to round him up and get over to the vet. So I thought I'd start a little early, but I don't want to dive too deep into it. I want to give some time for folks to catch up. Hello, Chadwick. Hello, Patrick. Thank you, Mr. Certainly, for letting me know we are live and you can obviously hear me. If folks have any questions before we dive into stuff, go ahead and plop those in there while we get started. I do have a smidge of a mailbag, which is exciting. Actually, did I show the sensor? I showed it on Show and Tell. It's too late. I'll maybe show that next time. I did get a bit distracted before here. We'll see. Any questions to start with? I've been doing lots and lots of Flash stuff. Hello, Charles. It was sunny here, although it just looks like it got overcast. I got out for a bit of a walk around the block, which was really nice. No data. Did I stop? YouTube's okay, right? OBS looks okay, but YouTube says no data. Good afternoon, Gary. Mr. Certainly says, I just want to thank you, Scott. You cost me some money the other day. Your Pomona SOIC8 grabber inspired me to replace my low-quality ones with the box set from Pomona. Hello, Nino. Hello, Rodrigo. Rodrigo says, I just got my RP2040 yesterday, and it's amazing. All right. Excellent condition. Okay, I don't know why it was telling me no data. Did it let me know if it's hitching at all? It looks fine from my end. But I like to live on the wild side, and I tend to update. My box right before. James says 5x5. Cutie Pie says yep. John says good evening from the UK. Can anyone recommend a feather with a 433 megahertz LoRa plus CircuitPython? John, you're going to be better off if do we have a 433 megahertz feather wing? I would recommend the wing instead of having it built in because I think all of the feathers with the radios directly are a little underpowered at this point. But if you get the wing, then you can upgrade it as you go along, and you can also use more powerful ones. Davey says hello from Colorado. Granoful says, hello, Scott. First time catching the stream. Just started working on my Feather 2040. Excited. Awesome. Yeah, I love the Feather. The Feather 2040s are great. And they're going to get better here shortly. They're going to be a little bit slow right now because of the Flash stuff that I'm doing. Neradoc confirms that says, yeah, they are non-express M0s. So the radio feathers are, I don't recommend them. Get the feather wings if you can. Dexter says 3.5 TFT feather wing just arrived, connecting it to a Feather S2, which is exciting. All right, we're about there. Let's see, is David in the dock yet? We're gonna have to sync time codes at some point. Okay, let's, I guess, wait 2 more minutes. Any other folks working on the RP2040s? Having a good time with them? Ah, David is in the chat. Hi, David. you're coming up in all the chats now. Betagraph says, looking forward to the QT's small form factor. Yes, I 100%. There's a little bit of a delay on the QT and Itsy Bitsy simply because Limor was trying to decide what flash footprint to use. And then once she decided it, she discovered that a lot of the flashes are out of stock right now. So I think she found some. So that should be kind of unblocked. Hi, Bruce. Hopefully it's this nice up in Vancouver. It's quite nice here today. Hi, Kinger North. Hi, Kinger North. I've noticed you do a lot of videos on YouTube about CircuitPython. You should make sure and add them to the newsletter that goes out every week. We'd love to share them. Mr. Certainly says, yeah, I have a bunch of old M0 LoRa feathers. Wish I got the feather wings instead. All right, let's get the show on the road because, like I said, I usually go 2 hours or so, but today I only have 90 minutes. Johnny says, hi there, Scott. So 2040 today as well. Yeah, I feel ya. Okay, let's let me. Looks right enough. Okay, so housekeeping. Hello, everyone. My name is Scott, and I work for Adafruit on CircuitPython. CircuitPython is an open source version of Python designed for low-cost microcontrollers computers called microcontrollers. Here is an example of one. This is a Raspberry Pi Pico and has the RP2040 chip on it, as designed by the Raspberry Pi Foundation. Oh yeah, I was exactly 2 o'clock PST too, wasn't I? Great. Boards like this are designed by Adafruit, and we sell them. So if you want to support me and support Adafruit, go to adafruit.com and purchase all the different electronics that you can find on there. And if you want to look for different projects to do with electronics, learn.adafruit.com is a great place as well. So Adafruit is an open source hardware and software company. So all the work they pay me to do is open source, which is awesome, awesome, awesome. So if you want to chat with me and a lot of other folks, we have a Discord server, which is the gray box over here. That is, you can go to the URL adafru.it/discord to check that out. We'd love to have you. It's a ever-growing community of awesome folks. So this is a deep dive. It happens every week, nearly every week. Normally Fridays at 2 p.m. Pacific, but occasionally shifted to Thursdays at 2 p.m. In particular, next week will be on Tuesday. We're going to do our last ski day, I think, on Friday next week. So next week will be on Thursday after John Park's workshop. We do tend to start a little bit late, depending on how late John goes. It typically goes for 2 hours or more. Questions are welcome and encouraged, but beware that today is only 90 minutes or so because the cat has a vet that I had to take him to after. It's just his annual checkup. I was meant to do it in December, and then I didn't get around to scheduling it until January. And then by the time I called them in January, they're like, we're really busy. How about March? So that's what's going on today. And speaking of the cat, the last bit of housekeeping is that he is epileptic, which means he has seizures occasionally. He has had them during the stream. But he's been doing really well, so I don't expect that to happen, but just know that if I'm watching him and not paying attention, that's why. David G says, hi, sorry I'm late. I was watching Sandy MacDonald from Pimoroni first live stream on the Keybow 2040. Oh, neat. That's good. That would be great to add to the newsletter as well. And speaking of the newsletter, King North confirms that Anne has been adding most of them to the newsletter as well. So if you don't know, there is a Python for Microcontrollers newsletter done by Adafruit, but drafted in the open. So if you have any Python-y stuff to add to that, you are welcome to make pull requests to the draft. You can go to github.com/adafruit/circuitpython-weekly-newsletter, I think is where it is. And that goes out to I think it's 8,000 folks last time I checked. So it is interesting. And so we just want stuff related to that. So a couple more hellos. Hello to Deshipu. Hello to Tom Twist, who says 2 picos just arrived today. Johnny says Guten Abend to Deshipu. Tabletronics waves. Hi, Tabletronics. Emmett Ray says, hi, Scott. Ordered pico, but the postal office burned with my pico and other stuff. Oh, I feel ya. I think I was telling folks about an Oshpark order I did with USPS, and it just like got lost, and then all of a sudden showed up in Tennessee, which is nowhere between where it was coming from, Oregon, and here. But it did finally make it, which is good. Mark Gambler says hello. Keith E says hello. Hope all is well. And Bruce says, snow, rain, and Whistler today. Just got off the hill. Awesome day running in as I type. Yeah, hopefully. I was thinking about that. I need to check the weather since we are planning on skiing next week. Okay, so I think I have a quick mailbag. So I just thought this is an order that I ordered long ago, but I thought I would just hold it up because it's not that exciting. David says, I've had great success with USPS for most of my Adafruit orders. Yeah, generally they work well. So the first thing I got is another compute module board. I'll take it out of the bag so it doesn't reflect. I don't want the bag anyway. So I got, if you've been keeping track, I do have one of these already. When Adafruit got it in stock, Adafruit had the modules in stock, and then DigiKey had the I/O boards in stock. But I actually ordered this before that. I back ordered it through Newark, thinking they would get it first. So I got that, and if that's any indication of what the other two things are, I thought I would just look. So I got two compute modules to go with it. So here's a compute module, and it doesn't actually tell you which one it is, except it's the CM410200, which I don't remember. Oh, I guess I threw away the bag that said what it was. Let's see, this bag does not say. Oh yeah, this one's. I don't think I can reach the bag with headphones on, so I don't know what the other one is. But this one is a, let's see, it's a CM41040016, which the bag says is a RPi module for 4 gigs of RAM, 16 gigs eMMC Wi-Fi. So this is, I got one that was like pretty bare bones and one that was not so bare bones. So I have more Pi 4 stuff for when I finally get around to doing native CircuitPython on the Raspberry Pi. Although I was talking to David about it earlier, so maybe I'm hoping somebody beats me to it. But I'm like about to turn the corner into Bluetooth land, which is super exciting. It's something that I wanted to do for a long, long time. And the nice stuff about the Bluetooth stuff that I want to do in the next couple weeks, is Trevor, our iOS dev, is also like in pace or in sync. So it's going to be him and I and maybe some other folks teaming up and really hopefully doing all this Bluetooth work. Bad Abby says, I'm excited for the Pi Unora carrier board to come out. Yeah, me too. It was my idea, so I'm super excited to see Timon come out with it and see what people think. 12DJ6 says, just got Picos from Canadian DigiKey. Took 4 weeks for lead time, but then 1 day for shipping. Nice. Picos are exciting. Johnny says, woohoo, mailbag. I did get more stuff, but I actually already put it away. I got a new soldering iron, which is very exciting. I haven't used it yet, but I cleaned this a bit last night and there as well. And then the shirt is Hacktoberfest. So Hacktoberfest is something that DigitalOcean runs every October, usually. And it is, if you contribute like so many PRs to open source projects, they'll send you a t-shirt. The last one was either a t-shirt or planting a tree, and I was like, I hate the earth, I want the t-shirt. So this is 2019's, but I do have a 2021 as well. So we'll keep doing that. We do that as part of CircuitPython as well. Mototima says, I only wish the Payunora had the PoE header. I assume that's what IPU. Yeah. Mark went with the t-shirt too. Okay, so let's... So I splurged on... So Mr. certainly asked, which iron did I get? And it looks like you're like 30 seconds off, David. So I'll just plop that in there. Maybe my time is running too fast. So I splurged a little bit. What got me thinking about it originally was Chris Gamble talking about getting a Thermaltronics. But then when I looked at the Thermaltronics, I was a little wary of how they were all out of stock on Amazon. So let me pull it up. I went with a JBC, which is like twice the cost. But I had seen a thread here that I'm pulling up on. So Jeff Kaiser here, desktop, asked folks about like JBC irons, and there's a lot of folks who are in this electronics world saying like JBC is the best. Really awesome. So I went with the JBC, and I got and I haven't used it yet, so I can't tell you what I think, but I'm quite excited. I got the compact station here. And it's funny, I actually realized after figuring out that they're in Barcelona that I've like been in their lobby. I like met a drone company there when I was in Europe right after I started working for Adafruit. And I had been doing drone stuff prior to Adafruit. So I visited somebody there, and JBC is in the same complex. So I was like, I remember looking at all the equipment and how expensive it was and being like, I'll never get this. But I don't know if these compact ones were ever there, but it was like $600 total. But I've been doing more I've been doing more soldering recently, so I really wanted something that was much quicker when you hit like a ground plane and you have to pump out heat. So these are supposedly really good for that. So that is what I got. I haven't tried it yet. I'm supposed to. It was a bribe for me finishing this part of the office that I haven't actually finished yet. I have to do. I think I'm gonna do one more kind of feathering of the paint, and then I'll be done and be able to like put this all back together. But I'm gonna do that tomorrow. So technically, I can't play with it until then, I think. Okay. So if you have questions, feel free to ask them. But I thought I would just... I detoured this morning. Let me show you what I detoured in. So Logic is here. So Logic is a logic analyzer software. And sorry, I don't have the overhead hooked up because I actually needed... Oh, let me move this around. This is where I keep my like stream status. It's like right below the screen edge there. Okay, so this is Logic, and I have a Logic Pro 16. I've showed this before, so if you want to see my setup, check one of the previous streams. But what I'll do is I've got a feather. Sorry, I can't show this because it's all hooked up, but I have a feather. I have my feather with the SPI socket on it, and then it's going into the Saleae. So I just want to do a capture because I want to show you. What I did is I worked on my SPI Flash analyzer. So if I hit reset and hit start and then let go, it'll capture. And I'll just hit stop. So what I was working on is I actually added simple parallel support to the SPI Flash analyzer that I have. So now what we can do is we can zoom in here and one thing that's interesting is the code.py it's running is a blink, and it blinks every 400 milliseconds. So you can see when code is, I know that's kind of small, but there's a gap of 400 milliseconds between flash loads, which is when it's loading code off the flash. And so if you want to see what it's loading, what you can do now is you can zoom in, and it's doing a quad access, but I just added support so that not only is it analyzing the quad reads, but it knows quad word read, which is a special mode that the Gigadevice stuff supports, which has only two dummy cycles instead of 4, which means that you save 2 cycles, and then it now also does it does the continuation stuff that the RP2040 uses. So the way that the RP2040 init works, and we'll kind of dig into this because this is what I want to wrap up, is like I have everything working, I think, and so all I've got to do is like make one more final pass over all my changes for the Flash stuff, and probably add some docs and fix the CI, but should be able to get a pull request out for the support for different Flash chips on CircuitPython on their RP2040. So that's kind of like the work that I'm wrapping up, and I said even in the title of the stream, like, we're wrapping this up today. I'm ready to move on. So I thought we've done that before where we look at all the changes, and so I have to do that anyway before I make the pull request. Mototimo says, Jason Kreidner from BeagleBone.org was asking about the state of CircuitPython on Zephyr, and I realized I never heard the two in the same sentence. We haven't done any work on it. MicroPython has a Zephyr port. I don't know the state of it. I know that Marine's been keeping it up to date, so that's been cool. But for a while, they didn't have a way to do like dynamic pin muxing, and I think they added an API for it, but I haven't actually looked. So it might be doable now, but I'm not sure. Not sure. We tend to do our own thing. Like we're very tied to tiny USB instead. I'm much more of a person of having like a lot of repos that are independent. Hi, Sean. Happy Friday. Okay, so I mean, maybe Saleaes are expensive for everybody, and they are, but they're a worthwhile tool, especially if you're doing Flash stuff. So you can see here that like it's doing a read, and then checking status register, and then you can see that it's going into quad word reads. He probably meant MicroPython. I don't know. I've talked with Jason about CircuitPython. Hopefully he wants CircuitPython. Hello, Unexpected Maker. David asks, what bandwidth do you need for this analysis? So, you know, for doing this sort of capture, you don't actually need that much bandwidth, because you can actually, like with Flash chips, you rarely actually have issues if you just slow it down. Like everything will run slower, but it'll run the same. So if you do have a logic analyzer that can't be super quick, you can just you can just slow down the Flash and then look at everything that's happening. Unless you're having signal integrity issues, and then that will be different. Unexpected Maker says DSLogic is a solid and cheaper alternative for a logic analyzer. Yeah, I haven't tried it. I really would like. I have this Tiny Logic Friend project that I mean to get back to. Like, there's no reason that all these micros can't be low end logic analyzers on their own. Like, somebody just needs to make an open source protocol across the two that captures like pin naming and stuff across the protocol. Yeah, I've started working on it, and I want to get back to it at some point. But like, PulseView's great. I had to fix a bug when I was looking at it, but yeah. Like, PulseView already has a quad SPI analyzer, but I mean, Logic 2, this is like the newer Logic 2, and they've done a great job, and it's all Python, which is great. So it's just like the analyzer that's doing all this is all Python. It's just unfortunate because you have to like plug a low-level analyzer in, and then you can get the output of that into Python. So there's a couple tricks that have to happen here, but like if you're ever doing SPI Flash and you're having reliability issues, being able to see what's going on is like super helpful. And Jeff and Limor, Lady Ada have already just kind of circled back to the IMX RT, and like we're going to be doing some Flash stuff for that as well. Okay, so let's go. And if you want to install it, if you are a Saleae user, what you can do is if you click extensions here, you'll see that I have this SPI Flash one here, and it says it's local. That's my local version. Yes, this is under. Anthony asks, is this under Linux? Yes, it is. I'm running on Arch, and Logic 2 is like, what's it called? The like Chrome thing. But if you have Logic 2 installed, what you can do is you can scroll down and you'll find the other version here, the SPI Flash version. And this is the wrong version. 0.80 is the older one, but it emailed me to tell me it got 9. So you want 0.90 if you want the quad SPI stuff. It has the up-to-date README, so I don't know quite why it's not everything, but that should be super handy. And I had this code written for quad analysis already, where I was just taking in a CSV export, and then I realized that like I could probably just do it in here using a parallel, and so I did that this morning, and so it's good. It'll be helpful the next time I do SPI Flash stuff as well, or if anybody else is doing it too. Okay, so I have two main browser windows open right now, and this is my Flash one. It's just like a ton of data sheets for Flash. Anthony asks, what hardware interface are you using? I have a Saleae Logic 16, which is like the top end. It's like not cheap, but it's pretty awesome. I don't know why they don't just tell you. Yeah, so the Logic Pro 16 can do 16 inputs. I rarely use an oscilloscope. I hate these pop-ups. But yeah, it's been pretty awesome. Tan says, my favorite Friday stream. Hello! Welcome to your favorite Friday stream. Okay, so they're pricey, but this analyzer, yeah, it should work with that too, with the lower ones. Let me know if it doesn't. Okay, so let's pull up my changes and go through them. So what I've done is I've Mr. Certainly points out, Saleae and Digilent have had several price increases over the past few years, so my 2 cents is if you need something, get it sooner than later. They're not going to be cheaper. Yeah, but hopefully in the future we have much cheaper options that aren't Saleae. Like, yeah. Especially as we get into IMX, one of the exciting things about the IMX RT is that they're USB high speed. So you should be able to pump like more sampling data out of that as well. Yeah, there's plenty of hardware that could do it. It's a software problem, not a hardware problem. Yeah. Unexpected Maker says Saleae is an awesome kit, but super pricey, which is why I got a DSLogic. But I'm keen to see how your project MCU-based version evolves. Yeah, I mean, I'd like to do it. Like, so much of what I want to do is just software bottlenecked. But I think it's always important to point out that, like, yeah, Saleae is like hundreds of dollars, like maybe almost 1,000. But like, if you're working like I do in this space, like you quickly, that your time that you save quickly adds up to hundreds of dollars. So having good tools is important. And underrated, I think, too. I think, yeah. Some people consider their time free, and it's important to realize that your time isn't free. And so if you can have tools that make it better, then they could be worth it. Okay, so let's look at this RP2040 Flash, and I'm going to get a unicorn here as I compare, I think. Because my personal fork was forked originally from MicroPython, I get this like terrible offset. And then when I switch it to Adafruit CircuitPython as my base, now it's on master, which is an old version. Keith E says, there's a real cost to fighting software. Just getting something that works is so helpful. Yeah, it is. For sure. Okay, so if I switch it to main, this will work. Okay, so here's how we have it set up. So let's just go over this. This is also going to be my, like, before I make a pull request sort of thing. I do want to actually see, it looks like, it doesn't look like the CI ran at all. So I'm going to want to do that too. I might make an open, after let's go over this, and then I'll make a draft pull request and see. I kind of suspect the CI will not be happy. Okay, so I've temporarily switched Pico SDK to the Adafruit version. The reason is I had to make a Pico SDK function call that is static, currently non-static, so we can use it. It's the call to run a command to the Flash. And the reason that I need that is because, oh, and I should test that as well. I don't think I actually test that code. But what I've done for the RP2040 is we actually don't bake the size of the Flash into the binary anymore. What I have it doing is I have it reading a standard ID from the Flash that tells us how big it is. And then that will dictate how big we make the file system. So that's something I should test. Okay, so that looks good. So I'm just going to collapse them as I look. So you'll notice here that I also added a subrepo for under data. So data is a new top level folder, and I'm adding this NVM TOML. I just got pinged by Melissa. Okay, so there I added the data/NVM TOML. I added this D Raspberry Pi. This is switching indentation. So I've added some build stage stuff. So whereas we were taking a stage2.c from the Pico SDK, now what we're doing is I'm running a Python script to generate it instead. So this Python script is called gen stage2, and it takes a Jinja file, which is like a pretty common templating system for Python, and it takes that C file, Jinjas it, and then generates a stage2.c, which then gets compiled as normal. And this is related to, so what I also added doing for the Pico is I'm moving, we have some code already designated as ITCM and DTCM, which is stuff I did for the IMXRT, which is TCM is tightly coupled memory. And on the IMX, there's, because it's a Cortex M7, it fetches instructions differently from data. It's got like 2 separate memory ports. It's Jinja with a J, Jinja. Yeah, so what I'm doing is I'm using those designations for stuff that should be in tightly coupled memory, and I'm putting it in, I'm using it on the RP2040 to put code in RAM. And the reason I'm doing that is if the code is in RAM, then I don't need to load it from the Flash as I want to execute it, which means that the stuff that's cached from the Flash doesn't need to include the stuff that's in RAM. So the hope is that, like, by taking the code that you're always going to use, like the VM, and putting it in RAM instead of leaving it in Flash, it means that like you'll free up more space for caching in the cache itself. So I'm doing that in this change as well, and that's what. So this -R means that the binary doesn't include the DTCM BSS section, which makes it like the binary really, really big. It makes it like 250 megabytes large because of the address space. So I had to remove that. Okay, so let's collapse that. Next up, we have changes to all the board files. So you'll see we're removing total flash size. Internal flash file system equals 1 is moved to the port configuration because like all of them are going to do that. And now we also have this external flash devices, which is the same definition that we have in other ports like the Atmel SAMD for the external flash. It works differently, but it's defined the same way, which I'm pretty happy about. So here we're just removing and defining. And these IDs here have to match the IDs that are in the NVM TOML. I think all this Python-y stuff is new. But I'm pretty excited I'm pretty happy with it, having a central location. So here we can see that I had to copy the boot stage 2 linker script into our folder out of the SDK because it adds these dot stars, because our section names are not just dot entry, they're like dot entry dot the section. So we have it ourselves, and this is what tells us when we've overflowed, which is nice. And then this is a new script. I don't think I showed it last week. I'm not sure how far I was last week. But this is the script that takes in the Jinja template and produces the actual C file. So I'm using Typer, which is something I used for Cascade TOML as well. And it basically automatically creates CLI interface, command line interface, based on Python and Python types. So it will automatically take like the first two arguments and make sure that they're paths. And then this last argument is an optional string with a default of empty string. So what you could do is if there's a comma in SKUs, we split it. Otherwise, we just have a list of 1. And then we filter, we create a set of filters that we pass. So Cascade TOML, I think as I showed it last time, was just a command line application. But what I've done is I've split it apart a bit so that you can basically use it as a library instead of it using it as a command line. So you can see I'm importing Cascade TOML, and then I'm calling filter TOML. So I give it the path. So this is the root path. So this is where all of the TOML definitions for NVM, which is non-volatile memory, is. And then I give it SKUs, which is now the filter for everything. So what it returns is a list of fully cascaded definitions for all the flash. So it's basically like, given these flash SKUs, give me all the settings for each of them. And then what this script is doing is it's figuring out the least common denominator for all the flashes that you've picked. So if all of your flashes can do quad word read, like E7, then it will produce code that does E7. If some of them can do E7, but some of them can't, but they could all do EB, which is the quad read with 4 dummy bytes, then it'll produce that. And if it can't do that, then it'll fall back to the 03, which is like a very slow read, but that all flashes should be able to do. So we're just checking that there were SKUs to begin with, and then a couple helpers make sure that they all have a particular key and that it's true, and all match make sure that all of them polyfill for SPI, yeah, basically. All match make sure that they all have the same value. So you can see here we're checking quad enable status byte. This is which status byte quad enable is in. Bit mask tells you which bit it is. Continuous status write is one way of setting the quad enable. Split status write is the other way. Some can do both. Some can do one or the other. Turns out. And so this will then figure out, like, is there a way for us to do the status writes for all the flashes that's the same? If not, it falls back to 0.3 again. And then there's this E7 quad word read as well, which all the Giga devices can do, which is on the Feather RP2040. That's why I support it. Then we figure out the max clock speed, which I don't think I'm actually using. You can see here that I'm saying if... So there's actually 3 states to these 2 status write ones. There's true, false, and none. None meaning that they're mixed. They don't all agree. So continuous status write is none and split status write is none means that for all the flashes we picked, there's no one way to write the quad enable bit or write the status register. Therefore, we can't do quad. We can't set the quad enable bit. Otherwise, and I think, yeah, there's also quad OK here as well. So there's this check that says the enable status byte and the enable bit mask also have to be the same in order to do quad. So we default to read command with 0 wait cycles. If quad is OK and we can do quad word read, then we'll do quad word read and rate 2. Otherwise, we'll do EB and 4. And then you just throw that in a dictionary and then load the template, render the template, and write it back out. So that's what Gen Stage 2 does. Here's the linker changes for doing the ITCM and DTCM stuff. So it takes about, I think, 10K of RAM, but it should be worth it. It should make execution faster, which is the goal. Here's internal Flash file system. Here are the changes I made to the SDK, which I actually have a pull request out to the Raspberry Pi people to incorporate. Maybe they'll pick it up. There's a comment that says, like, maybe make this public. So I think they have to have some debate about whether that's actually what they want. Okay, so here's the stage2.c Jinja, and I think this is where I was last week. I was trying to get the quad stuff all going. Maybe I also spent some time trying to read the capacity at that point as well. Let's just go over this. So we have some includes and some defines. I changed some of the defines at the top here based on whether we're doing quad or not. Because they're like used in multiple places. So that's all the same. So this is all Jinja stuff. So if you see, like, it looks like it's gonna pick out. It's highlighting based on Jinja. So we'll be able to see that. Regular like commands, sreg data. I think I went over this right. So we store the link register because we need to know whether we're coming from real code or from the bootloader. We'll do that at the end. We set up the data lines, and if we're doing quad, we'll set all of the data lines rather than just the input line. Disable the SSI, set the baud rate, or the divider, which implies the baud rate. We delay 1. And then basically what it does is you have to kind of like, you switch modes as you start up, depending on the commands that you want to do. So this is the most basic, and this is the setting that we need in order to just like set the status register. So we'll set that mode, we'll enable it, and then what we'll do is, depending on the status register here, and I don't think I tested all of this code, but it works for the cases where we're using it. We can fix it later otherwise. So this is like, depending on which status byte you have, either read the first one or the second one. Then you get the quad enable bit mask as well. And then if it doesn't match, it means that quad enable is not enabled. So what you do is then you set write enable. We have wait and read, so it waits until everything's done, which means chip select is gone back high, and then it reads the FIFO of whatever it is. I had one bug where I wasn't matching my writes to reads. Like I was writing 2 bytes and reading 1, which meant the thing later that was trying to like know the second byte was something was wrong. So like getting those matching was a pain. And then here you can see, like, if we're doing split status write, we do this thing, which allows us to just do one write. So we write the command and then we write the value. Otherwise, if we can't do a split status write, we do a status 1 write. But if we're writing to the second byte, we do an empty 0 first before we give the quad enable byte, and then we wait. And then we wait for the write to complete, which is another issue I was having. This was not working correctly, which meant I was getting to this later stuff and it was failing because it was in the middle of actually doing a write. So we disable. So that's, at this point, the quad enable is set, which means we can now switch to quad if we're doing quad. So we disable again. We set up to do a single read, but this format here is also the same format as if we're not doing quad. So this gets used if we're not doing quad. Or that's shared. There's two control zeros, which is really confusing. So if we're doing quad, we have this intermediate state where we re-enable, we send the read command we're going to do and make sure we read 0, 0, 0, 0 with the continuous read mode set, which is basically a way to save the 8 clock cycles to send the command again. So that's why you have to do like one special read at the start for the Flash to like get into the continuous read mode. And then once you're in there, you can set your final settings, which means that there's like, if you look at the data sheet, they say like we modified this peripheral to do this fancy thing. So if instruction length will be 0 in that case, which means that it actually puts the command after the address, not before, which is a bit of a hack, but it allows you to send that like, yeah, keep in the same mode bit. And this is where we set wait cycles. We say how long the address is and read instruction. If you're doing quad, read instruction will actually be that continuation mode. It won't actually be the instruction itself. And then transaction type tells it whether it's quad or not. And then we re-enable, and basically we're all set up at this point. So the first read that we'll see is actually this one here. So no, I take that back. This is making the pointer. And then we set the Detour. So this is the vector table offset. This changes where all the interrupt handlers mapping is located. And then this is the first read we actually do. We read the first entry of the vector table into the stack pointer because that's what is stored there. And then the second entry is the reset handler address. So we read it and then we branch to it and we're done. We have two helpers. We have wait and read, which is just wait until the transmit FIFO is empty. So that will be 0 when everything's out of the FIFO. And then we wait for busy to finish. So the busy bit is high as it's transmitting and drops low. And this I had an issue with as well. I wasn't correctly waiting. So what I was seeing in the Saleae, I was seeing like 5 of 8 bits being done. And I was like, we should be waiting for this. Why aren't we? And it was because of this. These 2 loops were wrong. These are correct now. And then I have the read part. So for given count, we read in the result, but we only return the last one. And then to read the status, we send status twice, and then we wait and read 2. Okay, so that's the Jinja file, and that should, I think, cover kind of all of our bases currently. There's a chance, one thing that we're not really handling is that there's a chance that boards may want to do dual mode, which is a mode that a lot of these flashes can do where it works like quad, but it's only 2 lines instead of 4. But it's all different commands, so it wouldn't be hard to support, but I don't think any of the RP2040 boards use it yet. So it would have to be added there and all the data to NBM TOML as well. Any questions? I don't know how many more files I've got. I'll keep going through it. So far it's looking good. So once I get all the way through it, I'll be able to do make the PR. I do need to test erasing and recreating the file system. I think that's the only time we actually need it. But then again, you know me, I kind of work in the way of like, I'm pretty sure it's correct, and then we get it out and we find the issues and we fix them. Okay, so here what we're doing is we're storing flash size statically. This is in ports, Raspberry Pi, supervisor, internal flash, so that only applies to RP2040. This binary info is fixed in the flash image, so we just pretend that we have a 1 megabyte block device just to the Pico tool. It won't be correct, but it's fine. And then what we do is we do a read here that reads the RDID register, and the third byte back is power of 2 size, and we just validate that like the data we get back is within the kind of reasonable range, because there is one manufacturer that does it wrong. And so it'll default to 21, which is 2 megabytes. Otherwise, it sets power 2 to that, and then flash size is 1 to the power of 2. And then you can see here that the one place where we were using total flash size, we replace it with the static flash size, which should happen after flash init. So that's that. Okay, so this import is the DTCM, ITCM stuff. So basically, as we do port init, before we call any of those functions, we need to copy the contents of those functions. So I just cribbed this kind of straight from the IMXRT stuff. This usually happens in reset handler, but because we're using the Pico SDK, we don't actually have access to the reset handler. But everything that we're storing in that region is like has to do with running the VM. So by the time port init is called, like port init's the very first thing in main, so it's still plenty early. Oh yeah, Kmatch says hopefully we get an appearance from Trevor on the deep dive when the BLE stuff gets integrated with phone apps. Yeah, hopefully. I know Trevor is in New York, so I'm not sure how well the timing works for that, but I could ask him about it. And he's a new dad too, so he's pretty busy. But yeah, so this is just the case where we copy from the Flash version to the RAM destination, and then what we also do is we set the Flash copy to 0, which should flush that line out of the cache. So I was starting to think about like the execute in place cache stuff. So that's that. And then I had to change a few things because we're doing internal flash file system with external flash devices. So I had to be more, I had to change a few of these checks here. This is the thing that changes the macros for the TCM stuff. And I added Raspberry Pi, blah, blah, blah. Again, this is just changing a check. Yeah, and that's it. It looks really clean to me. So the last thing I want to check is, actually, let me just see if the erase works while I'm thinking of it. So I'll toggle data on. So CircuitPy popped up, and one of these is, I guess it's this one. So if we look at properties, we can see that it's 3 megabytes, which is not correct. Actually, it might be correct. Because this is the feather that has the it has the, I don't know what flash chip I actually have in the socket. Okay, let's just eject it and we'll run erase file system. It should be 3. I mean, that looks right. It's not the default. And we have 2 ACMs, and one of them is the time codes. This one is hello world. So this is the Feather RP2040. So I'm gonna import storage. Hopefully this is working. Erase file system. and it disconnects, and then it should erase, and then it should restart. Yep, there we go. And now we're on there again. And let's just do the same thing we just did, which is click it, and we have another hello world and properties. And now it's 7 megabytes. Okay, so I must have an 8 megabyte in there. Maybe it was wrong before. It's possible that that could be lying to me, but I think it's correct. I don't actually know what this flash chip is, but that's good enough for me. I just wanted to make sure that it worked well enough. People will test it and let me know if I got it wrong. All right, so that's looking really good. I'm actually very pleased with that. So the other two things I wanted to check were, this is adding Python dependencies to the build. So I actually just want to go over the Learn Guide about building CircuitPython. What does the chip ID say? What do you mean? I can't read the chip itself. Wait, maybe I can. Yeah, this says 64 on it. So this is an 8 megabyte chip. So that was correct. It was correct to flash it to that. The 4 megabytes originally might have been from a previous version. So, yeah, the electronic ID does indicate the flash size. Let me show you. I've got, if only I could find a flash datasheet here. Here's one. So one of, if you're, have I not shown a flash datasheet? Let me just go over this, because I have a ton of them here. I don't think I have. Have I? So this is for the WinBond25Q32. So 32 is bits, which means it's divide by 8 for how many bytes it is, or megabytes. Table of contents is really handy. As always, if you can have a reader that does this too, it's really nice to skip around data sheets. So let's see. Sections wise, we had general description, package types, pinned descriptions, block diagram, status register. Hamslab says, "Hi y'all, just got out of a meeting. My new chair rocks. If anyone was wondering, what chair did you get?" That's the follow-up question. Okay, so if we're looking at a flash data sheet, which confirmed to me, folks, that I haven't gone over this, but so the two spots that I look the most is status and configuration registers. This will tell you what status byte and what bit quad enable is, so that can be really handy. And then the instructions, in particular, the start of the instruction section is usually really helpful. Here you can actually see. I didn't see this. So there's this device ID and instruction set table. So this is actually what 9F is loading. So it gets an EF and then it loads these 2 bytes, which is not right. That's not what I'm thinking. I don't know what that's for. So instruction. So it returns 16, which actually seems kind of low to me. I thought it should be higher than that. So what we can do is look in the NVM TOML WinBond 32 JVIQ. Yeah, it says 16. My math is not right. Let me double check. Internal flash. I said between 20 and 30, but it should be returning 16. What is 21? Okay, let's get Python out. Python 1 to the 16. 65,55536. Yeah, that's definitely not right. I don't think that's right. I would expect it to be like, this datasheet must be wrong. Like 1 to the 21 is 2 megabytes. 1 megabyte is 1 to the 20. Yeah, so it doesn't support anything below a megabyte. But this datasheet is not right. But that's weird because this capacity listed... Oh, you know, it's hex 16. That's what's messing me up. It's 22. Okay. Hex is complicated. HamsLab has a chair that was highly rated on Tom's Hardware and it was $154 on Amazon. Check the Discord if you want to see that. Okay, so capacity we can load from the chip, and it's just like the power of 2 for the capacity. And it's generally correct, but it's not always correct. So that's why I bound it a bit. So that's all correct. That works. Oh, I was looking at the data sheet, wasn't I? So the other thing that's really handy is this overview of all of the commands that you could do. So you can see here that like 90 is this one, and it has 2 dummy bytes, a 0, and then manufacturer and ID. But the JDEC ID is the one that we use, which is 9F, and then these things. And then read unique ID 4B is also used. This is actually how we get a unique ID for the RP2040, because the RP2040 chips don't have a unique ID at all. ATMaker's Bill asks, how consistent are these commands? Is there a standard? There is a standard by JDEC, but it's it varies some. It varies some. So some of these you're just gonna find on everything. Like I think 9F is like always gonna be the same. Write enable is gonna always be the same. Like the core commands are the same. Where a lot of the variation comes is what quad modes are supported, and then also how you enable quad mode. So if we go back to package types, what we see here is like the 8-pin flashes that have these pins that do kind of 2 things. Like this is WP is write protect. Yeah, Luke Wren says there are many standards, not just one standard, and that's part of the problem. And that's something that I'm trying to capture here in the NVM TOML. So if you look in NVM TOML, there's an nvm.template.toml, and I have comments here for all of these different settings that are captured in it. So you can see here, quad enable status byte says status byte number that contains the quad enable bit, 1 base to match flash docs. This one says supports writing 16 bits to the status register's first 2 bytes via command 0. So the template is actually very handy for knowing what all of these settings are. And so this is meant, the NVM TOML is meant to be a like use case agnostic database, and I've said this before, of human modifiable and readable, but also machine modifiable and readable. And I've been pretty happy with it. I added like a rename command to the Cascade TOML as well for like renaming some of these. So I started doing that. But it's meant to just be a catalog of stuff. And it's working out pretty well. So that, yeah. So one of the things that varies is how you switch these pins, like write protect from write protect to being IO2, and then hold or reset from that to IO3. And so that's where this status and configuration register gets really is really handy. And what you're looking for in particular is the quad enable bit. It's usually QE. So you can see here it's status 9, which means it's in the second byte and it's the second bit of the second byte. And then we ignore all these others, all the other ones. And then, like I said, this instruction table is really handy because it can show you what the instruction is and then also like the pattern of how to use it. So like what comes after it. And you can see here like all the different modes for reading as well. So here you can see like EB is 3 bytes of address and then a dummy, but this dummy has a super 11, and then there's 2 more dummies. And the super 11 says the first dummy is M7 through M0, and it should be set to FXH, which is interesting because it's actually A0H for continuous stuff. But yeah, so this is a great way to look at different Flash sheets. The other thing, I guess, ordering information could be really handy as well. Good afternoon, Paul. Espressif has an ESP32S2 HMI dev kit. Is that HDMI or HMI? Paul says, I just ordered, among other stuff, 2 Feather RP2040s. Awesome. Hope you like them. I'm really happy with mine, even though one of them's been quite abused. Ordering information is really handy because it helps you decode what the SKUs are. And I'm still not quite sure with the win bonds in particular. There's Qs and Ms, and Qs. And if you look on their website, they've got, if you look here in this tab that I've got open, you'll notice that they have a regular part number and a DTR part number, and they're both production, and they have 2 data sheets. And it's not clear to me whether like all parts are DTRs as well, or these are just for old stuff. It's confusing to me, and I tried to order some, but you can see here that like if it ends in Q, it's a fixed quad enable, so we don't actually have to set it. And then it's backwards compatible, which I'm not sure whether that means that like some of the changes. Oh, human machine interface. Okay. For the S2. And then M is you have to set quad enable, and it has a different device ID. So in NVM TOML, it has 2 entries, 1 for each. Because the device ID, the NVM TOML stuff originates from what CircuitPython had, and CircuitPython had device ID. The way that its external Flash stuff tries to work is it loads that RDID, JDEC ID, and then it tries to pick it from its options, and only if it matches verbatim will it actually use it. Which is why I'm trying to like move away from that so that we just trust the capacity of it instead. Okay, so I think that's about all of the Flash stuff. The last thing I want to do is I actually want to just make sure that people will still be able to build CircuitPython now that I'm adding these dependencies. So one thing I want to check is just github.com Adafruit CircuitPython. I just want to look in here. Documentation, code search, contributing. So I think contributing here is old. Let's just skim this. Ways to contribute. Build instructions here. Okay, perfect. So this just links to the build instructions. Hamsab says, Limor was talking about erasing the Flash taking a long time in manufacturing. Might have been on Desktop This Flash has a chip erase command that is quicker than doing it block by block. Yes. Chip erase tends to be. But if she was using UF2, which she might have been, UF2 does the erase block by block, which is what you want, because if you did it all together, you would like blow away your file system when you did just a portion of it. The Tinkerer says, about to solder the headers in the RP2040 feather. Awesome. It isn't the most recent Python build info here. I don't know. Probably not. Paste and go. What does this say? I think we're better about keeping... Oh no, it has pre-commit in it. This is the problem. So I do want to have this there. So yeah, one thing we want to do is be better about this as well. How do we get there though? Like this is where I link people. Okay, so here's something interesting. It has this pip3 install hyufman. I think what I want to do is I want to add a requirements.txt into CircuitPython and then have all the requirements so that this line like wouldn't have to change. Found it. Todd found it by trawling the repo. So that's not where I look, but I think all right. Randy's advertising that they have their own Pico breakout board design. Okay, so I can update this, and although I don't know if it says what directory you're in a terminal window, do that. Let's just take a look at. So this does pip3 install, brew install. WSL. And then manual setup. All right, so I think is it requirements.txt or dev requirements.txt that's the right file to add. Fetch the code. Oh. We're going to want to do this first. Run your build. When to make clean. When in doubt, make clean. Okay. Choosing a different SPI Flash chip. There we go. That's handy. What a good guide. All right, let's just look at dev requirements. See if there's a proper, oh, it's requirements -dev. Like requirements.txt. I think that's what we want, right? Let's see what this says. Could you indicate in that guide that a precompiled MPY cross exists? I don't know if that's the right guide because, I mean, we could. But like that's not really library. Like that guide's specific to building CircuitPython core. Okay, I think we can just do requirements.txt. I just want to make it simpler to install stuff. So text. I think that's the last thing I need to do. Sure. And then I can pull it. I was like, it's a little weird because I'm adding like the Jinja dependency and I'm adding the Cascade TOML dependency, but I had both Dan and Jeff looking at it and neither of them said like this is bad. Which I kind of expected them to and be like, whoa, what are you doing? So I'm pretty excited about the NVM TOML stuff. Like Jeff was already like, "Ooh, we should use that on IMX as well." So I'm hoping I hit it, like designed it right. Okay, so let's just what is this setup.py? Oh, look at that. Wait, can we just build it? Does this just work? This is for let's just do requirements-dev. This is for pushing CircuitPython stubs, which we should definitely do. I just don't know if it's working still. And I only want to have one requirements-dev.txt. Okay, we require hyufman. We require Cascade TOML. And we require Jinja 2. I think that's it. Ports. Raspberry Pi. So anything that those things depend on will be installed as well. But we can keep this list to a minimum. Let's just look at here. And am I importing a... Oh, typer. So we'll do typer as well. Typer. Okay, so those are all the things that we need to build. And I think that's all I need to add. Where is this other doc? Building. I might as well update this. Debugging, code quality checks. I think maybe I'll leave that. AT Makers Bill says, is there a separate build process, etc., for just the Blinka libraries? Does this impact them? This does not impact them at all. No, and in fact, we want to better document all the pre-commit stuff for all the libraries. So that we might make it, I may take an interlude at the start of next week to just write basically this code quality thing up in all the readmes if it's not there already. You know, I think I needed polib as well for pre-commit. So I'm just going to add that as well, if I'm remembering right. And let me just do in my repo. Git status. Okay, so I have a new SDK commit because I had a typo. And I'm source there pip install requirements dev. Well, bam. Okay, so I installed Huffman because I didn't have that installed. But it validated that it could install all the things that I listed, which is good. Okay, so that looks good. I'll add it to building as well. Although I feel like I should also... Oh. This links out to the building. This is a quick start only. Submodule sync. All right, well, we'll do that. Johnny says, just a heads up, Scott, you've been streaming for 80 minutes. Indeed. I've got an alarm on my phone set for 3:30 though, so I won't forget. And I like that time gives me some time to get, like, he's just sleeping. He's easy to grab. It's a nice thing about having the door closed too, is he can't get away from me too much. Foamy Guy says, I'm joining in late, but I'm not sure of all the full context of what I'm working on, but I don't think Blinka libraries typically need to be built. They are Python only, I believe. Yes. So I think that's one reason to look at the readmes. I think we need to be clear that libraries tend to not need to be built. Only if they're going to be distributed do you need to do that. Okay, so I don't actually want to update the Learn Guide quite yet because it's not checked in. But let's... Oh, you know, the other thing we need to check is the CI. Because the CI will break and all of these boards will stop building if we don't fix it. So let's see what build CI does. It sets up Python and then it does pip install. Oh yeah. Look at that long list. You know what? I think what we should do is let's just move all of these into there. Control X. And then we'll do pip install R, and we should be in the right directory. Requirements-dev.txt. And in here, let's do... Like, I just want to have, like, these are all the things that you should have installed. I think we can put comments in here, too, for docs. For translate check. If I fork CircuitPython and make a local change, will the CI run and compile it for me on my repo? I believe so, yes. I think these are for pre-commit. These might be old too, but that's fine. Not sure what these are exactly for, but we shall unify towards one thing. Okay, build. Polib twice. Thank you, Gareth. So Huffman is for string compression. And this is for nvm.toml. Yeah, that's what like requirements.txt is nice for. It's just like, I just want all the things we need for the environment. Yeah, so those must be for these other checks, which is fine. MPY cross Mac. Okay, so we might have more. We won't need it for MPY cross. We will need it here. Pip install. Let's make sure that all these are. Just dump them in here. Hi, Daniel. Thanks for joining in. I'm just about to wrap up and take the cat to the vet. But I think my timing should be really good. I should be able to get... I should be able to get this PR out. Here we go. Ugh. Might just alphabetize it. Yeah, I could do that too. I do like to say what they're for. Let's check these others. Although these don't build, so maybe it's okay. Well, just the repository is going to be there. And here too. It's like, yeah, I'm going to install extra stuff as a result, but then I only have one place to worry about. Yeah. Request, click set of tools. AWS CLI. I don't think AWS CLI is actually for there for pre-commit, but this is for uploading artifacts. I think. All right, good enough. Let's just run the requirements install one more time. And I'm getting AWS CLI and stuff. That's fine. It worked. Okay. We want all of this. Add. Python deps. Failed. What did it change? Oh. Any questions for the last 8 minutes? Get my PJP key. This should be exciting. It should make it really easy to maintain Flash info for all of our CircuitPython stuff. So I'm quite excited. And I don't think I need to rebase. Quite excited to have a central database of settings for Flash. Even if I haven't moved everything over yet. Ooh. Restarted my computer. And let's make this pull request. I won't even draft it. I should be able to this comparison. Is there a TOML parser for CircuitPython, or is it just CPython? There is not for CircuitPython. That's a good question. There's a couple for regular Python though, and there's the one that I like to use is called TOML Kit, and the reason I like to use it is that it preserves enough information for formatting, so it allows you to round trip with minimal. Like it preserves all the comments and stuff, which is really nice. And so I'm using that, and you'll see that like, oh, you want these three things, and we're merging it together. Like it merges comments together too, which is really nice. Like I like the output a lot as a result. Okay, so this got both commits, and we haven't actually tested the we haven't tested the CI, but this will test the CI for us. It's a best case stage 2 for all the possible flashes, and we'll work with others of the same capability as well. Flash size. Are there other languages like CircuitPython, like Circuit C++ or Circuit.js? No. I mean, there is a JavaScript, I think it's called Esperino. It's kind of like the equivalent. And then if you're down in C land, you can use, like, CircuitPython has C-level APIs that mirror the Python APIs, which is what we use internally. Configured based on the Flash. There is Lua, JavaScript, several Lisps, several Forths. This also moves some code and data into RAM so that its space is freed. XIP cache. All right, labels, enhancement, RP2, and some basics. Lady Ada just asked if wanted to jump in. This also moves TCN designated code and data into RAM. So create pull requests. Yeah, next week. Oh, Lady Ada says they just put in 700 RP2040 feathers. So if you want to get them now. And it's adafruit.com/product/4884. TinyGo. Gareth says CircuitPython is the standout choice for getting started with microcontrollers. AT Makers Bill says we're looking for a way to do config files on both Arduino and CP. For now, we're just using JSON. Chris Young is working on pulling the config out of the Arcada libraries to use standalone. Was wondering about the TOML format. The nice thing about TOML is that it has comments. JSON does not, but JSON is supported. I just need one for my RMA. Did you have a bad one? I'll put the link in the YouTube as well, and for completeness. Let's wrap up. Let's go. All right. Well, thank you everybody for hanging out. Sorry it wasn't the full 2 hours, and we missed Lady Ada, which is a bummer. Next week will be on Thursday because we're going skiing hopefully next week. I just have to remind Lady Ada, so you all are now tasked with the job of reminding me to remind Lady Ada as well about Thursday next week. Okay. Let's see. Super happy to conclude this Flash stuff. I think it's in the right direction. And hopefully, you know, folks will find Cascade TOML and the NVM TOML really useful for other projects as well. The goal is that it's you know, kind of a project agnostic repository. So would love to see it become the tiny USB of Flash settings, I guess. Looking like next week we might like take a look at library process stuff a little bit, but then getting onto BUILDIng workflow stuff is next up on the list. If you are using RP2040, I recommend always keeping the latest. Dan just released beta 4, so thank you, Dan. And we're like very close, and Dan's pushing to doing a 6.2 thing as well. So there's my alarm. Yeah, short stream. I have a vet appointment in 45 minutes, so I wanted to make sure and give myself time to get everything ready and throw him in his crate and stuff. So, interesting. Awesome. Well, thank you all. We'll see you next week on Thursday. Again, we're in the Discord, adafru.it/discord. And also, if you want to support me, support Adafruit by going to adafruit.com. Now's a great time because the Feather RP2040s are in stock. So feel free to check that out. And with that, I'll give Spook some pets. Well, he has nowhere to run. And he doesn't realize that he's going to the vet. So I'll give Spook some pets to wrap up. And we'll see y'all next week. It's just his annual checkup. It's no big deal. He's just got to get his rabies booster. And he's been doing so well. So I hope they say that he's been doing well too. Is it chilly in here? The window open? Kitty potted. All right. Thanks, everyone. Oh, he's like, Dad, pet me more.